In Chapter 8, we will look more at right triangles. Section 8.1 is the Pythagorean Theorem and its converse. The Pythagorean Theorem says that in any right triangle, the sum of the areas of the squares on its legs equals the area of the square on its hypotenuse. So in a right triangle, remember that the hypotenuse is always opposite your right angle. And that will always be C. It does not matter which leg you call A and which leg you call B. So then the formula for the Pythagorean theorem says that A squared plus B squared equals C squared. Example 1 says a conveyor belt carries bales of hay 35 feet up from ground level to a hay loft. The end of the belt is 42 feet from the barn. How far does a bale of hay travel on the conveyor belt? So you see from our diagram that we have a right triangle. We know that one of our legs is 35 feet, the other leg is 42 feet, and we're looking for our hypotenuse here. That will be the distance the bale of hay travels on the conveyor belt. So using the Pythagorean theorem, you can say 35 squared plus 42 squared equals C squared. So 1,225 plus 1,764 equals C squared. So remember, square your legs and then we can add them together. So 2,989 equals C squared. Then to solve for C, take the square root. And we're going to round our answer to the nearest tenth. So that would be about 54.7 feet. So that is the distance that the bale of hay travels up the conveyor belt. Number 2 says, a truck driver uses a portable conveyor belt 13 feet long to unload cartons to a loading dock 5 feet above the truck bed. How far is the lower end of the conveyor belt from the edge of the truck? So let's first mark our triangle. So we have a right triangle. 13 feet is the length of the conveyor belt. It is 5 feet above the truck. We want to know its distance from the conveyor belt to the truck bed. So that would be here. So again, using the Pythagorean theorem, this time we know one of our legs, but not the other. So 5 squared plus B squared equals our hypotenuse squared, or 13 squared. So squaring 5 and 13, then subtract 25 from both sides, and then finally take the square root of both sides. We get that our other leg is 12, so that the belt from the length of the conveyor belt from the edge of the truck bed is 12 feet. The converse of the Pythagorean theorem says if a triangle has sides of lengths A, B, and C, and A squared plus B squared equals C squared, then it is a right triangle. So remember, the longest side is the hypotenuse opposite the right angle. So in numbers 3 and 4, we want to determine if our triangles are right triangles. So that means that the Pythagorean theorem would be true. So remember, we said it does not matter which side we call A and B for our legs, but it does matter that our hypotenuse would be C. So our longest side in number 3 is 8 square root 13. So this has to be C, and then I could call this leg A and leg B. So let's see if our Pythagorean theorem is true. Is 24 squared plus 17 squared equal to 8 square root 13 squared? Okay, so 24 squared, 576. 17 squared, 289. Now when you square something with a square root, so we're going to square both our terms, so 8 squared, 64, and then square root of 13 squared is just 13. So then if I take 64 times 13, I get 832. Okay, so combining like terms on the left, 865 equal to 832. Okay, that's not true, so then this triangle is not a right triangle. Same idea number 4. So our longest side would have to be our hypotenuse. Oops. And then it does not matter which leg we call A and which we call B. But that 6 squared plus 8 squared would have to equal 9 squared for this triangle to be a right triangle. So is 36 plus 64 equal to 81? And actually it's not. We get 181. They are not congruent. So again, this one is not a right triangle. A set of 3 numbers that can be the lengths of sides of a right triangle are called Pythagorean triples. So in number 5, we want to determine if 39, 65, and 52 are Pythagorean triples. So in order to be Pythagorean triples, then the Pythagorean theorem would be true. So again, the longest side would have to be our hypotenuse, or C, and then it does not matter which leg is A and which is B. The question is 39 squared plus 52 squared equal to 65 squared? So first squaring our numbers. Then combining like terms. We do get a true statement. So then the answer is yes, these 3 numbers are Pythagorean triples. Here is a list of common Pythagorean triples, and the first one is probably the most common, 3, 4, 5, and then examples of this: if you multiply all 3 of those numbers by 2, you get a 6, 8, 10, or if you multiply them all by 3, you get a 9, 12, 15. Some other common Pythagorean triples: 5, 12, 13, 7, 24, 25, 8, 15, 17, and 12, 35, 37. Again, if you multiply all 3 of your sides by the same number, then that is also an example of that Pythagorean triple. In number 6, we want to find the length of AD and AC. I'm going to call AD B and AC C. So AD is part of our triangle on the right and our triangle on the left. Now the triangle on the right, I know my hypotenuse and one leg, so I'm going to use those numbers to solve for AD, which we're going to call B. So using our leg of 24 and a hypotenuse of 30, I can say 24 squared plus B squared equals 30 squared. So 576 plus B squared equals 900. Subtract 576. So B squared equals 324. Then take the square root. Get B is 18. So we're going to use that 18 to find AC. So let me mark that on our triangle. So we're using 18 and 8 to find AC. So we can say 8 squared plus 18 squared equals C squared. So 64 plus 324 equals C squared. Combine like terms, so we get 388 equals C squared. Then take the square root. So square root of 388 is C, And if I want to simplify that into radical form, this would be 4 times 97, or 2 square root 97 is C. Alright, in number 7, we want to find the length of ZW and WY. So let's call ZW A, and we'll call YW or WY B. Alright, first let's find the length of ZW. So A squared plus 12 squared equals 37 squared. So A squared plus 144 equals 1369. Subtract 144. We get A squared equals 1225. And then take the square root. So we get 35. So we can say ZW equals 35. And then let's find the length of WY. So that's in our triangle on the right. So we can say 12 squared plus B squared equals 20 squared. 144 plus B squared equals 400. Subtract 144. So B squared equals 256. And then take the square root. B equals 16. So that tells us WY is 16. We can use the Pythagorean theorem to determine if the triangle is acute, right, or obtuse. So remember, if the Pythagorean theorem is true, that both sides are equal, the triangle is right. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the other two sides, then the triangle is obtuse. And if the square of the length of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is acute. So in 8, 9, and 10, we are going to determine if our triangles are acute, right, or obtuse. So using the Pythagorean theorem, does 15 squared plus 20 squared, does it equal 25? Is it greater than or less than? Remember that the hypotenuse is always the largest side. So squaring our numbers first. Combining like terms on the left, we get 625 and 625. So they are equal, which tells us this is a right triangle. In number 9, we'll take 10 squared plus 15 squared and 20 squared. So 100 plus 225. And we have 400 on the right. Combining like terms, we have 325 and 400. So this is less than, which tells us since the square of the hypotenuse, well, what could be our hypotenuse, or the biggest side, is greater, this is an obtuse triangle. And finally, number 10, 7 squared plus 8 squared. We have 9 squared. So 49 plus 64. And we have 81 on the right. So we get 113 and 81. 113 is greater. So if the sum of our squares of our two sides is greater than the square of the third, we have an acute triangle.